Question 9 of this exercise says in figure 10.13 that you see here, xy and x dash y dash are two parallel tangents to a circle with center O. So if you see this figure, you see that there is a circle in the figure. This point O is the center of that circle, and xy, this line here, and x dash y dash, this line here, these two lines are parallel tangents to the circle. And another tangent AB with point of contact C intersecting xy at A and x dash y dash at B. So this segment here, AB, this is also a tangent to the circle. The point of contact of this tangent is C, this point here, and this tangent intersects xy at A, this point, and x dash y dash at B. Now we have to prove that angle AOB is equal to 90 degrees. So this angle here, angle AOB, which is subtended by the tangent AB at the center O of the circle, we have to show that this angle is equal to 90 degrees. The proof is actually quite simple, and to understand the proof, let's first join the center O with the point of contact C. Okay, now if you compare triangle OAP with triangle OAC, it's easy to show that these two triangles are congruent, and therefore this angle OAP or angle PAO will be equal to angle CAO, this angle here, correct? Similarly, it's easy to show that the triangle OBQ is congruent to triangle OBC, and therefore the angle QBO, which is this angle QBO, is equal to angle CBO, which is this angle here, right? And now if you look at the angles PAC and QBC, so observe these angles carefully in the figure. Angle PAC is this entire angle, and angle QBC is this entire angle. What do you think is the relationship between these two angles? Well, the sum of these angles is equal to 180 degrees because these are co-interior angles, and therefore the half of their sum will be equal to 90 degrees. But what is the half of their sum? So if you take half of angle PAC, you get angle OAC, which is this angle, and if you take half of angle QBC, you get angle OBC, which is this angle. So OAC and OBC add up to 90 degrees, and from there, using the angle sum property, it follows that this angle must also be equal to 90 degrees. So this is the proof. It's very simple. Now let me write it out for you step by step. Okay, so as I said, we will begin by comparing triangle OAP with triangle OAC. So I'm directly going to make use of the fact that these two triangles are congruent. It's very easy to show. If you want, you can pause the video for a few moments and think about how you can show that these two triangles are congruent. But I'm going to use this result directly, that triangle OAP will be congruent to triangle OAC. And from here, it follows that angle PAO is equal to angle CAO. So angle PAO, this angle here, is equal to angle CAO, and let's call both of these angles angle 1. Okay, so angle PAO and angle CAO is equal to angle 1. Now let's compare triangle OBQ, this triangle, with triangle OBC. Again, these two triangles are congruent. I'm going to make use of this fact directly. If you want, you can pause the video and think about how to show that these two triangles are congruent. So triangle OBQ is congruent to triangle OBC, and from here it follows that angle QBO is equal to angle CBO, correct? So angle QBO is this angle CBO is this angle. these two angles must also be equal. So let's call these two angles angle 2. Alright. So both these angles are equal to angle 2. Now because xy and x dash y dash, they are parallel, it follows that this angle PAC, this whole angle, plus this whole angle QBC, their sum must be equal to 180 degrees. So let's write this. Since xy is parallel to x dash y dash, it follows that angle PAC plus angle QBC, this is equal to 180 degrees. And why is that? Well, simply because these two angles form a pair of co-interior angles. Okay, and this means that if you multiply both sides by half now, so half of angle PAC plus half of angle QBC, this will be equal to half of 180 or 90 degrees. But what is half of angle PAC? Well, this is simply equal to angle 1, this angle here, half of angle PAC. And what is half of angle QBC? This is simply angle 2. Correct? So now we can write angle 1 plus angle 2 is equal to 90 degrees. Now I want you to think about the triangle OAB. I'm going to highlight this triangle for you, triangle OAB. Okay, in this triangle, two of the angles are angle 1 and angle 2, and we have just shown that their sum is 90 degrees. And from here it follows that the third angle, which is the angle whose measure we want to find, which is angle AOB, it follows that the measure of angle AOB will also be 90 degrees. So let's write this. In triangle AOB, the triangle that I've highlighted, angle AOB will be equal to 180 degrees minus the sum of the other two angles, so angle 1 plus angle 2, and this basically follows from the angle sum property. So this is 180 minus angle 1 plus angle 2 is 90 degrees. So 180 minus 90 is 90. So we have proven that the measure of angle AOB is 90 degrees. Okay, this is what we had to prove. So this completes question number 9.